Thanks to those tuning in. I'm HB Duran from VideoGameNewsSource.com, and we're here with Nelson Rodriguez from Akamai. Is that how you would pronounce that?
You say it, yeah, Akamai, that's right.
Yeah, I figured it was more like the Japanese pronunciation by the spelling. But
It's a Hawaiian word.
Oh, Hawaiian. Okay. What does it mean? Do you know?
It means clever.
Oh,
yeah.
Well, that is clever. You have to be clever enough to pronounce it correctly, apparently. Mm-hmm. So, Nelson, thanks for joining us. I was unable to make GDC this year, so I really appreciate you taking the time to talk with us about some of the important messages that you had at the show that we were unable to cover on our ends. So tell us a little bit about yourself. I know that you've helped launch games like Halo 3, Tekken 5, Assassin's Creed Brotherhood, Creed Bros, as a lot of us call it. And so what does that entail from your end? People think of the developer or the publisher, but Akamai is kind of in the background. Tell us what you guys do.
Yeah, so my own background is that I've been in the industry for just under 10 years, and at this point, I've been at Akamai for about a year, and Akamai's main focus in the game space is on doing three basic things. One is delivery, right? It's like making sure that the game gets downloaded to whatever device the player is using and that it gets downloaded quickly and easily. The second component is accelerating the network connections for folks, right? So if you're logging into a server or if you're trying to get a matchmaking, if you're trying to get a match made, if you're logging into multiplayer, so the network component of that is something that we accelerate, and we also do a lot of that work on the website. If you're buying a game off of a website, we try to make that really fast. And the third part is security, is protecting servers, whether it's a game server or a website from malicious, from attack, right? So somebody who's trying to hack into a storefront database to try to get your personal information, that's the kind of thing that we protect against. So those are the three big areas, right? Getting you the game and keeping it updated, getting you logged in and connected to other people, and protecting the server.
Now, as gamers, we're no strangers to such attacks. For those uninitiated that don't understand why, the PlayStation Network goes down or why Xbox Live goes down, and then we hear, oh, it was hacked. Tell those that don't maybe understand what a denial of service attack is. What causes that?
Yeah, so a DDoS attack or a denial of service attack is really interesting in that it's become really easy to do these days. So you can go onto a web service and pay 20 or 30 bucks and target a server that you want to overload with traffic. So basically, the way a DDoS attack works is that you take a server that's trying to serve up content to people, right? Let's say it's a game server or a web server, and you point a lot of fake traffic to it. So computer-generated fake traffic to it. It'd be like, imagine an ATM. If you were trying to get to an ATM to take your money out, the way a DDoS attack works is it basically sends a bunch of fake people in front of you to try to get money instead of you, so that you've got this line of 200 people. It basically shuts down the system, right? It makes it so that the requests can't go through in the way that they need to. So that's a common form of attack. The interesting thing about it, though, is that a lot of times a DDoS attack is a smokescreen. It's used to distract a company so that other attacks can go on the back end. So application layer attacks that are trying to access information can happen while a DDoS attack is distracting your security team or distracting your network team, trying to just keep your servers running. Right?
Wow.
It's a common reason for DDoS attacks, actually, right? So you can launch a DDoS attack just because you're upset at a company and you want to shut them down, but a lot of times it's really just a way to cover another attack.
And how are companies that, like, for example, your clients, I guess you can't really speak for those that you don't represent, but how do companies like that attempt to, anyway, prevent attacks of that nature?
Yeah, so funnily for Akamai, we ended up in the security business initially many, many years ago as a side effect of the work we already do. So, and that kind of speaks to one of the methods. We have a massive network, right? So we have hundreds of thousands of servers all over the world they're there really just to deliver content. But because of that size of network, it means that that flood attack doesn't affect us in the same way, right? So one of the ways is basically to use somebody like Akamai as a CDN that can absorb the attack. So if I use the ATM example, Akamai is like having 100 ATMs in the same mall. So you kind of can't make it overrun because you'll always the end user will always have access to it. So that's one way, right? Is just ensuring that the scale of availability is so high that you can't knock a server down. The other way, which I think is a really critical way, is to use computer learning and keeping a database of attacks and keeping a running log of the kinds of attacks that are happening so that you can study how attacks happen, what they look like, right? So the work that we do, we have a team. Actually, I have multiple teams all over the world that work 24 hours a day, 7 days a week. It's almost like a spy facility, right? You can see like this, we've got these big screens, and we've got a bunch of people in front of computers, and they're literally, if you come to Cambridge, you can walk by our office and see people working all day long, and they're there monitoring traffic, and they're there looking at patterns. So where are attacks coming from? What does an attack look like in terms of the kind of the file sizes that it's pushing? And that helps us recognize, oh, you know what, this is an attack. So rather than just absorb it, we can knock it off at the edge, right? So we describe our network as an edge. We're near every end user. So because we're near the end users, we're also near the attackers. So we can say, you know what, this is an attack, and stop it from coming all the way through. And there are a lot of sort of really technical, geeky ways that we do this, but it's through lots of vigilance and lots of insight that then turns into more and more information that we use to make computer-based decisions about the traffic that we're letting through. Some people will use, some companies, a kind of older way to do things is they'll use hardware. So they'll set up a box in their server farm to protect and to monitor traffic, but that's like, it doesn't scale as easily, and that was the older method that was used. It's the kind of thing where you would use this box to try to watch traffic that was malicious, but then the box would get overwhelmed by the malicious traffic, and then you're back to the same problem that you had before. So it's worked out really well for us to have this approach be cloud-based, right, to be distributed.
So as far as this type of security goes, is there anything that the user base can do to help protect themselves from such an attack, or are we at the mercy of wherever our game servers are?
I think there are two approaches, right? Or there's two ways to look at it. One is for sure there is what the game publisher is responsible for, that you don't get a choice in, but you do get a choice in what games you play, right? You get a choice in the companies that you decide to support or not support, and so one choice is to make sure that the game that you're playing has a reputation of solid security, that the company that's publishing it has a reputation of protecting your information and of protecting servers. And it's not easy to do, but I think that's one. There's another component of this that the publishers can't help with, and that technology can't help with, which is just not lending your friends your password, right? Like not lending your friends your login so that they can farm for you while you're away, and not sharing one single account with a bunch of people, and being really cautious about the emails that you get and the phone calls that you get, because some of the attacks, and I'm not going to call out specific ones, but some of the big attacks that you've seen in the gaming press over the last couple of years, some of them were social engineering based attacks. Like they stole information from somebody who had it, or they got access to a server through a human, and it really didn't start as a technological attack. And so that's one of the things that you can do. At this point, I feel like almost all of us have had some kind of hack happen to us. Where it almost feels like every other week you're getting an email that says, your password may have been revealed, so please change it. The fact is you have to change it. That's habits that there's almost a online security hygiene that we can all practice to make it harder for our own information to be stolen.
Well, that's good practice anywhere. Social engineering is, a very famous way to hack. I've seen videos where, gosh, I can't remember his name, but there was a guy who literally put on like a polo shirt and put a name tag that said IT guy, and he walked right into this building and all up and around, and no one cared because subconsciously they saw IT guy and they just let him through. And it was just an example of social engineering where if he had had malicious intent, he could have just taken whatever he wanted.
Yeah,
So,
yeah. It makes me want to put on a shirt that says like donut tester, and then
yeah, there you go.
walk into the donut shops and go, look, I'm just don't mind me. I just want to make sure everything's safe.
Yeah, exactly. I'll be the coffee tester then. But I need to make sure that
Well, we just got to get the name, the badges printed up.
we'll have those made up, and then we'll meet back up. So speaking of retention, you were talking about choices of which games we want to play and what publishers we want to work with based on their security. One thing that Akamai was talking about in the briefing at GDC was retention, and you were saying that 95% of gamers leave. So tell me about that. What causes that kind of turnover?
Yeah, we had a panel discussion on this exact topic, right? So we had a couple developers and an analytics guy and somebody who's responsible for download managers, so like heavily PC based, and the audience was a couple hundred people, right? It was basically a couple hundred developers interested in this topic, and the topic was why do players leave games and how do we mitigate it? So it's something that everybody's thinking about all the time. I think part of what happens in our industry is that the problem feels really hard to fix. So I'm lucky enough to get to talk to developers and publishers from pretty much every company all over the world, and when we talk about this topic of player abandonment, I almost always get the same response. People say, it feels like there are too many issues or too many reasons, and we don't know how to fix it, right? Because people say, well, and this came up at a discussion that I was having at DICE, at the DICE Summit in Vegas a couple months ago. Somebody said, well, it could be because the game is terrible, it could be because of the tutorial, it could be because the first couple levels are too hard, it could be because we asked for money too soon, it could be all of these things. And I think the way we like to look at it is there are problems that are sort of art problems. Does the game feel right? Is it, does it flow in the right way? And then there are problems that are fixable. They're like very tactical, technical problems, and for us, those are the ones that we focus on. So in other words, games, maybe you don't like the graphics of this game, or maybe you don't like the way the story is unfolding. But for you, if we could fix the load time, if we could fix the download, if we could fix the login, those are things that are going to at least retain a percentage of players that may have left for silly reasons like that, right? So we did a study, we worked with EDAR, which is a games industry research firm, and we asked a couple thousand players what makes them quit out of a game. And some of the stuff was what you would expect, like my friends stopped playing or the game got too hard. But some of the other answers were the game took too long to load, or it was updated so often that it stopped me from playing. Other people would say the game doesn't update often enough, and so the game wasn't there are these technical reasons that for us are easy to address, right? How do you accelerate the download so that the person doesn't notice how long it's taking to install? How do you, when it's time to update your game, which you need to do if you want to keep it fresh, how do you make it so that I'm not sitting on the bus for 4 minutes waiting for it to update? Like I wanted to play, I didn't want to wait. To us, those are the kinds of things. These are like points of friction that are almost dumb, right? Like these are points of friction that you could easily fix, and that's what we like to focus on. So that's what we spend a lot of our time talking about.
I'm always surprised to see newer games with long load times. Because that was something I expected, back in the day. We'd be playing, like Nintendo didn't even load that time long.
Yeah.
And then, like PlayStation started to get into a lot more detailed graphics and, bigger levels and things like that. And so the load time would last, a few seconds. And if you were really into the game, it felt like forever. But then I was playing a game on Vita that, seriously, I had to time it, because it was part of my review. I'm like, this is ridiculous.
Yeah.
How long it takes to load every level. Like, I could literally get up, go get something to drink, come back, and it still would be loading. It was just ridiculous. And so how do you improve load time, for example? Is it server-based or in the files themselves, or how would you fix a problem like that?
Right. So that's where it starts to get really can get complicated and technical, right? There are load time issues that might be hardware based, right? In the case of a handheld device or even a phone, there maybe it's just a hardware limitation, right? There's a RAM limitation. Um, I've heard some developers talk about the fact that they knew that the load time for the first scene was really long, but they wanted the first scene to be amazing. They wanted to include so much stuff in the first scene that they were willing to include a minute and a half load time. And I think really there's still some willingness to have those kinds of long load times if you know your game session is going to be really long. But as we start to have short game sessions, as like we're playing games that are 10 minutes long or 15 minutes long, just for that time that you're sitting playing it, it gets harder to tolerate a minute and a half load time, right? So
Mm-hmm.
accepting that there are going to be hardware limitations or legal limitations that make it so that you have to have the logo screens, pop up for 30 seconds or whatever. There's a lot that can be done about intelligently separating what needs to load and what doesn't. There's a lot that can be done about server-based loading. So saying, look, we're going to only deliver the first 100 megs to you or the first gig to you, and then when it's time, we'll deliver the rest. But when we deliver the rest, we have to make sure it's really fast, right? So part of our value proposition for the last almost 20 years has been that we've figured out super fast routes on the internet. We figured out a way to algorithmically determine the path that data should take, and we can store data on servers that are really close to end users to cut that time down, right? So to us, one of the clear ways that some publishers are solving this is saying we're going to give HP only part of the game, and then as she's playing, we're going to load the rest in a way that's so fast and so seamless that she doesn't notice it. And the RAM loading times and hardware loading times, I think, are still a challenge that haven't been fully solved. But the being able to use the network to solve it is something that's happening right now.
So what does it take to update a game like for a major update? So you had talked about updating too often, which I've seen. Like they'll fix one bug and then you have this huge download file, or it updates every day, and you're like, I just wanted to play. And even though it only takes maybe a minute or two, it's still frustrating because, for me especially, like I don't have a lot of free time to play just for fun. I'm a game journalist, so when I do play, it's usually for a review or for a story, and so that prized time when I can just sit down for myself and play, sometimes it's been so long that I have to sit there and endure updates and things like that. So for people like you helped launch Halo 3, for example, so things like that, what does it take to coordinate a large update across, thousands of users? Is there any kind of special procedure that you guys have to follow, or how difficult is something like that to pull off?
Yeah, it's interesting because those are a really big deal. And just to clarify, Halo 3 is I worked on Halo 3 while I was at Microsoft, and the stuff that we do at Akamai, it's that scale, right? We don't talk about all the titles that we work on one by one, but if you've played a big game in the last year, Akamai probably delivered the initial install or the update. It is in a lot of ways like preparing for a big live event. It's like preparing for the Super Bowl. That's what the TV stations have to do to prepare is what a lot of these companies have to do is they have to make sure that there's enough capacity to handle just the throughput of all the data that they're going to be pushing. And then this gets to picking the best routes and making sure that the data is really close to end users. So it would be like if you imagine that a game update is like a printed report that you had to get from your office, right? Let's say you and I were sharing an office. If there's a printed report you had to get and it was 100 pages worth of a printed report, one thing you don't want to have to do is print a page, walk to the printer, get it back, print the next page, walk back, right? So that kind of thing, that happens in data. I mean, the funny thing is that is one of the ways that data gets distributed at times. So that's something that you solve, right? Is you say, we're going to put the printer really close to you. That's what we do by putting the server really close. So a publisher says, I know I'm going to distribute this game in Japan and in Korea and in the US and in Germany. I need to make sure that I have the content on servers in those regions to distribute it to those users really quickly. The next thing is this is like a dirty secret that I learned about once I came to Akamai, is the public internet is really slow. The public internet, the path that things take for something to get from you to someone else, or for if you go to a website that's just using the public internet, that route is not direct. That doesn't go straight from that server to you. It gets bounced through a bunch of different ISPs, and it gets bounced through a bunch of different routers. And that's not happening because it's best for you. It's happening because maybe it's cheap, right? So like for the ISP, it's cheap for them to use this kind of crazy roundabout route. So what a publisher has to do if they're launching a really big game is, when they work with a company like us, is figure out a way to skip those routes. To say, well, we have a shortcut, and we know how to hop from one ISP to another in a more efficient way, and we manage that relationship with those ISPs. So those are two ways, right, that you prepare. You get the data close to users, and if you can't get close enough, make sure that the route it's taking to get to them is really is as short as possible. So those are two big things.
Wow. So with the digital age, more often we're finding that games are not on disk, but they are downloaded. So what kind of stress is that putting on servers now, and how is the industry having to adapt to that new development?
Yeah, so funny. I'm old enough that every game was always bought physically from me, and we're at a point now where almost all PC games are digitally purchased. All mobile games are digitally purchased, and now console is the last holdout for physical, right? It's at a place now where about a third of the business is digital and 2/3 is still physical. And what I'm talking about is the initial game sale, right? Because if you look at EA, if you look at their public filings, they'll tell you they're making more money on digital than they are on physical. That's because it includes the DLC. But the initial game is still 2/3 physical in the console space, and that's changing, right? It's continuing to change. It's getting more and more digital. What happens that we see is the last year's spike in the network. So we move a lot of traffic globally. So we move sometimes up to a third of the entire world's internet traffic will go through Akamai at some point. So we see the traffic. Last year's spike becomes this year's average, right? Like that's what's been happening for years and years. We see a giant spike in traffic and just tons of terabits a second, and then the next year that's just normal, and then the new spike becomes the next year's normal. So basically capacity has to keep getting built out. One thing that's really exciting that we don't always think about in North America is there are parts of the world where the network performance is improving to a point where they're essentially coming online for games. So they had network performance that enabled basic web browsing. And there are parts of the world, we have a State of the Internet report that we issue, and we're finding that there are regions of, say, like South America, where the network performance is getting to a point where they can now, publishers who had ignored those markets for games can now start distributing games there because it's not going to take 7 days for the game to download. So it's an interesting balance, right? Like the network keeps getting stressed, but then people keep building out more capacity. So we're starting to reach parts of the world that weren't reachable before. So I mean, honestly, I don't know what the limit is going to be, the physical limit, but it's every year gets bigger.
So I don't know how much more time you have, but I guess what I'll end with is what's next for Akamai? For people that don't know what it is, or maybe developers that need a solution for Akamai, what kind of exciting things are going on that we can look forward to?
Yeah, I think we are doing some exciting work in multiplayer. So where we've heavily been focused on game delivery and on network acceleration for some parts of the business. Multiplayer is an exciting space for us. Accelerating the connection from you, the end user, to the server is something that we've been doing over the last couple of years, and it's starting to become bigger for us. Another thing that I think is exciting is there's a movement in the industry to using network performance as a component of your matchmaking. So not just is HB good, but is her network good, right? Or can we match her network to someone else whose network is similar? And I think as that space evolves, we have a really interesting part to play in that because we are so closely tied to the idea of network performance. So I think those are two really exciting areas for us. We already do business with most of the big publishers in terms of game distribution, but I think the multiplayer, both matchmaking and acceleration, is going to be exciting for us.
Oh, good. Do you think we'll ever lose lag in the future, or do you think that's going to be eliminated by, like, I live in a gamer house. My husband and I both game, so
Yeah.
our internet is really fast.
Yeah.
So hopefully in the future, then we will only be matched with those who have that same priority. But hopefully lag will not be an issue for everybody because that is very rage quit worthy, I'll tell you.
I know. Yeah, I think there's two parts of it. There's a physics part, which puts us in a kind of thrilling time, which is that we're getting near the physical limit of what can be pushed. I was talking to someone in Tokyo. They said to play a server to have somebody sitting in Tokyo playing with somebody in the United States, it takes 100 milliseconds just to cross the Pacific Ocean. Literally just to get data across, not with how slow your computer is or anything else, just the data travel across that part of the world takes 100 milliseconds. So when you consider like you've eaten up all your lag right there, right? So I think that it'll be interesting to see how that gets pushed. But there's a lot of clever stuff that folks are doing with acceleration at your router. So like technology in your own home router that helps accelerate. And then I know a lot of companies are talking about dedicated gamer networks. So so right now you're paying your ISP for a fast internet, but it's not necessarily just for gaming. And I think ISPs and lots of companies are looking at, well, what if we just had a dedicated network that dealt with real low latency and didn't have to worry about big files or whatever. It was just dealing with the multiplayer component. I think there's work being done there that could be really exciting.
That is really cool. Well, I want to thank you for your time today. I learned a lot, and I hope those watching this have learned something too. Where can we find more about Akamai? What is the website? Is it akamai.com?
Yeah, you can go to akamai.com and there's a games dedicated area which is akamai.com/gaming. And you find information about what we're up to and what events that we're going to be attending in the coming year.
Great. Well, I look forward to seeing you guys at future events. And thanks again for the insight. It was really interesting. And again, I really appreciate you taking the time to talk to me since I wasn't able to go to GDC and see the panel for myself.
No, yeah, we missed you, but hopefully we'll connect at some other time.
Absolutely. Well, have a safe trip to New York.
Thank
And you guys have a great day. And I think once I hit stop broadcast, it's going to completely dump everybody. So
you.
I'm not hanging up on you. So.
Thank you.
All right. Well, you guys have a good rest of your day. Thank you again. Bye.